Hello everyone, welcome to our channel Mathematics Pathshala. This is a problem of CSIR NET June 2024 Mathematical Sciences. This is a problem of real analysis part C. The question ID 704070. First we read the question. Let K subset of R be non-empty and F such that K to K be continuous such that this condition holds. Then which of the following statements are true? Option 1 says that if need not be surjective. So first we will examine that if is injective or not. For this, simply we take xy belongs to k be such that fx equal to fy. Then we will check if x equal to y or not. So using this given condition, we have mod x minus y less than equal to mod fx minus fy, and as here fx equal to fy, this is 0, so we must have mod x minus y less than equal to 0 implies that mod x minus y equal to 0, that is x equal to y. So we get that f is 1 1. Now as f is 1 1 and continuous, so we must have f is either strictly increasing or strictly decreasing. So without loss of generality, we may assume that f is strictly increasing. Now look at option 1, f need not be surjective. So if we choose simply k equal to this unbounded interval 1 infinity, and if we choose fx equal to 2x, then clearly f is a function from k to k and also satisfying the given condition, and f is yes, so if is also here 1 1 and strictly increasing. But if it's not surjective, as fx equal to 2x equal to 1 in this interval, but this has no pre-image in the domain because x will be half, which is not in k. So this is not surjective. So this f and k may exist where f is not surjective. So if need not be surjective is the correct option. Option 1 is correct. Now look at option 2. F must be surjective if k equal to closed interval 0 1. Okay, so for option 2, our k equal to closed interval 0 1 and f is continuous. So f is as f is continuous on this closed and bounded interval, that is compact set. So f attains its maximum and minimum. Now actually here we will show that f will be surjective. So from the given condition, if we take y equal to 0, then we get mod x less than equal to mod fx. So this condition we have for all x belongs to k. Now, so clearly from close interval 0 1 to close interval 0 1, this function without loss we have taken f is strictly increasing, and the strictly decreasing case is exactly similar. So this function may be like this, and in this case the function will be surjective. So suppose this case we can suppose where f is not surjective, that means f may be like that, or f may be like that, then the point which lies here has no pre-image. So for this, actually here we will prove that this f0 must be equal to 0 and also f of 1 must be equal to 1. We will prove this. And if this happens, then f, as f is continuous, f must be surjective, because any point lies between 0 and 1 has pre-image in closed interval 0 1 as f is continuous. So if we can prove this f0 equal to 0 and f1 equal to 1, then it will be proved that f is surjective. So first we prove that f1 equal to 1 and f0 equal to 0 is the similarly we can prove. So we only prove here f1 equal to 1. Sorry, f1 equal to 1. This is the only things which we have to prove. So f1 is definitely less than equal to 1 as f is a function from k to k. So if f1 not equal to 1, so we have say f1 equal to beta, and which is less than f1 equal to, we say alpha. F1 is, we can suppose f1 is alpha which is less than 1. So there must exist an element beta such that alpha less than beta less than 1. So now by the given condition we have f alpha less than f beta less than f1, and this is f1. So f1 is strictly less than f1, which is a contradiction. So we must have f1 equal to 1. And exactly in similar manner we can prove that f0 equal to 0. Now 0 and 1 have pre-image, 0 and 1, and also any point lies between 0 and 1 also has pre-image as f is continuous on closed interval 0 1. So f must be surjective. So option 2 is the correct option. But keep in mind, when k is closed and bounded interval, then f is surjective in this case. Now look at option 3. F is injective, and if is injective, we also proved that now f is injective, and f inverse from fk to k is continuous. So we can prove this. This is actually a standard result, that when f is continuous and 1 1, that is strictly increasing or decreasing, then this f inverse from fk to k will be continuous. But here we can prove this in very easily, that f inverse from this fk to k is continuous. We can prove this by using sequential criteria. So we take an arbitrary point y from this fk, and we will show that f is continuous, sorry, f inverse is continuous at y. Now to prove this, we can take an arbitrary sequence yn tends to y and we can show that f inverse yn tends to f inverse y, then it will be proved that f inverse is continuous at y. So now this yn sequence is taken from the domain that is fk. So for this yn, there exists xn belongs to k such that fxn equal to yn. And now we have supposed that this yn tends to y. Also we uh, we have taken y belongs to fk, so there exists some x belongs to k such that fx equal to y. Now this yn tends to y, that is f of xn tends to y, that is f of x. So that is actually limit n tends to infinity f of xn equal to fx, and as f is continuous, so we have f of limit n tends to infinity xn equal to fx, using simply the continuity of f, and then using the injectiveness of f, we have limit n tends to infinity xn equal to x as f is 1 1. Now this xn is actually our, as f is 1 1, this xn is actually our fxn equal to yn, so xn equal to actually f inverse yn. So this limit n tends to infinity f inverse yn equal to f inverse y. So what we get actually, we suppose that yn tends to y, and we get f inverse yn tends to f inverse y, and which implies that f inverse is continuous at y. So now look at option 3, that f inverse is continuous. F inverse is continuous at y, and y is taken arbitrary from fk, so f inverse is continuous on fk. So option 3 is the correct option, and option 4 says that f is injective, but f inverse from fk to k need not be continuous, but here f inverse k is continuous, so option 4 is not the correct option. So here option 1 to 3 are the only correct options. This is the solution of this problem. Thanks for watching.